हेलो। स्टार्ट करें सक्षम?
Yes sir, you are live. आप start कर सकते हैं.
Okay. Hello everyone. I am Rohit from What After College, right? And we are conducting a free webinar on IoT. And Mr. Saksham Madan is here to teach you about the basics about IoT, and he will give you the insights of IoT. What topics we will cover, and what is the future of IoT in the industry. And for further support, you can contact us. We'll share our numbers and email IDs. You can contact for any further assistance, right? Saksham, over to you.
Yes. Hi everyone. Okay. Am I audible to everyone? Okay. Hi everyone. So the first class, first webinar of the IoT series is about Arduino. Do you guys know what Arduino is? So Arduino is basically a development board using a microcontroller based development board. So first question is, what is a microcontroller? Microcontrollers are a small computer integrated on a single chip. They contain processing core, flash memory, I/O peripherals, RAM, peripherals such as clock, timer, PWM. I'll just explain all this to you in a while. Microprocessors are used for general purpose application, while microcontrollers are self-sufficient and used for specific tasks. Microcontrollers are an example of embedded systems. Okay, so using this particular image, you'll get some idea about what is a microcontroller. Microcontroller is nothing but a microprocessor plus I/O buses, ROM, clock, GPIO pins, RAM, ADC, buffer. What are these actually? Basically, if we compare a microcontroller to our body and a microprocessor to our brain, we'll be having an analogy of GPIO pins as a sensor input output pins. Basically, what are GPIO pins? GPIO pins are general purpose input output pins. General purpose input output pins means any pin or any port that is used to take input or give a output. Okay, general purpose input output. Then there's RAM, random access memory. We all know about that. Then there's ADC, analog to digital conversion. Every signal we entertain, a microcontroller or microprocessor entertain, is a digital signal, but sometimes we get a signal in a analog form. So for that conversion we need ADC pins, analog to digital conversion. What is the difference between analog and digital system? Analog, in analog we have output of sorry, 0 to 255, and in digital we have a output of 1 to 0 and 1 only. Okay, then there's buffer memory. You guys know what is buffer? So buffer is basically a memory that is stored, in which a system is stored while it's running. Okay, then there's IO buses. IO buses are basically input output buses. So we can translate them, if we are taking an analogy of a human body, we can translate it as a nervous system. A pathway from GPIO pins to a microprocessor. Then there's ROM, read-only memory. We all know about that. Then there's clock. Clock is a very important system in which our system is using which our system creates a timed output. What I mean when I say timed output, timed outputs are basically any output in which the output can be we can have a particular timed output or output at a particular intervals. Okay, for example, I want to run a LED after every 5 seconds. So what will I do? I'll just turn on the LED for a specific period of time, turn it off, then wait for 5 seconds, and then start it again. Okay. So I have a question over here. ADC and buffer, please. Okay. ADC is analog to digital conversion. Any input that is entertained by the microprocessor should be digital. But sometimes we get a uh, output in a form of sorry input in a form of analog. What is analog and what is digital? Digital is 0 or 1. Analog is 0 to 255. Okay, so for that particular system we need ADC, analog to digital conversion, so that whenever it goes to a microprocessor it is in digital form. Okay. Okay, so difference between microprocessor and microcontroller. Okay, Sandhya, using this particular diagram you can see that the difference between microprocessor and microcontroller is as same as the microprocessor is a brain of a microcontroller. Okay, as a human body, like if I term my human body as microcontroller, then microprocessor will be a brain. Okay, now comes what is Arduino. Arduino is an open source physical computing platform. It's a small microcontroller with a USB plug based on a simple IO board. IO is an input output board. Okay, development environment that implements the processing and writing language. Arduino can be used to develop standalone interactive objects that can be connected to a software on a computer. Easy to use hardware and software. It's intended for students, artists, designer, hobbyists, and anyone who technology, who tinker with technology. Okay, just uh, think like why we developed Arduino. Like as soon as we got a system, so if we go somewhat 20 years back in the timeline in 2020, like 2001 or 2000, we were having two different groups: a computer science students and the electronic students. So there was a huge gap between them. Like just imagine it like this: like if you are a computer science student, you know how to program a system. Okay, and if you are a this electronic student, you know how to program a system using a microcontroller, not a microcontroller, ICs and registers and all, and you know how to connect the system. So there was a huge gap. Like for a simple, even a simple application, we need two type of people over there, like a student from computer science and a student from electronics, just to assemble a system. So at that time there was a huge gap between a thinking and a system. Okay, so someone came with the idea to create a very simple system using a microcontroller. Okay, that was a Arduino. Okay, so here's the diagram of Arduino. I'm just gonna explain what everything over here. This is a Arduino Uno. It's a variant of Arduino. Atmega Micro. In particularly Arduino Uno, we have Atmega 328. Okay, analog outputs like over from here to here. Just wait a second. Over from here, I guess. Wait a second. Sorry. From here to here. Like we have analog inputs. Analog inputs means we have a ADC conversion over here. Okay. TX and RX LED. TX and RX means transmission and receiving ends. Whenever we are working on a system in which we need sorry, in which we need a system with a transmission or a receiving system, we use TX and RX. Power regulators, obviously, we need a power regulator to support and protect our IC, a basic microcontroller, that is Atmega. Over here we are using Atmega. There are also different companies and different organizations that manufacture different systems. Like a Raspberry Pi have a ARM based system and ARM based microprocessor, and there are also Atmel based systems. Then there's power. Then there's a FTD USB. Okay, what is FTD USB? FTD USB is basically, we have a USB system over here. You kind of a USB system that is used in printers to connect to our laptops or systems basically. So to convert the data coming from from a system to here to our microcontroller, we use this. Vidya, just wait for like 2 or 3 minutes. I'll tell you what's the difference between Arduino and Raspberry Pi. Then there's test LEDs. Then there's digital IOs, digital input and outputs. Which means we don't have any ADC over here. Then there's 16 megahertz crystal. This particular crystal is used to calculate and have a clock time, a clocked output. Okay. So there was a question: what is the difference between a Raspberry Pi and Arduino? So Raspberry Pi is microprocessor based development system. This is a microcontroller based development system. We can install a OS over there, operating system over there. We have an operating system over here in Arduino. Okay. Okay, different type of different type of Arduinos: Mega, Lilypad, Nano, Mini. So based upon what we need, like what type of application we need, we use different type of microcontrollers and different type of Arduinos basically. For example, in variable we normally use Lilypad because it's quite should I say thin, like काफी पतला होता है ये और आराम से किसी भी ग्लव वगैरह पे लग जाता है. Then there's Mega. For example, in a system we need a lot of input and output, or number of output is more than the Uno, if Uno can handle, we use Mega. Then there's Mini, again a smaller system, somewhat like 3 or 4 centimeter. Then there's Nano. So what is the basic difference between them? The basic difference between any Arduino is the type of microcontroller it have. For example, Arduino Mega has Arduino 32. Lilypad have Atmel 328P, and so on. So based upon the difference, Lilypad have different type of microcontroller. I'm sorry, I said 328P. So based upon different type of application, we need different Arduinos. We use different Arduinos. It all depends upon what type of what's our application and how do we use this. Okay. Then there are shields. What are shields basically? Shields are basically a add-on which we connect to Arduino for different purposes. For example, we have Zigbees. If you can see the fifth image over there, over here. Just wait a second. Over here, Zigbee. So Zigbee is a is basically a Wi-Fi based module. is basically a Wi-Fi based module that is used for communication systems. We have a LCD in third image, and we have a counter in third image. So basically, it's a kind of a plug and play and expansion to a Arduino. Okay. Sorry. External power. We should have been between 9 volts and 12 volt DC. So we basically have different adapters for the same. The minimum rated current is 250 mA. Sorry. Okay. Okay. I don't think these things are useful to you. Okay. So Arduino software. Let me show you the live IDE over here. Just give me a second. Just wait a second, guys. Okay, which one is better, Arduino or Raspberry Pi? Okay, Sandhya, basically it's based upon the application we want. If we want processing over there, uh, wait a second. Okay, yeah, we have it. Okay, if we want processing over there, then we will be using this what should I say, Raspberry Pi. And if we only want a task to be entertain a task to be the go on again and again, for example in your washing machine or in a LED something system, so we'll be using Arduino. Okay, so basically a microcontroller board is used to a microcontroller board is used to develop a system in which a process goes again and again. Like if we want a repetitive process, for example a red light or something like that, okay, we'll be using a microcontroller based system. And if we want processing, like if I want that let's say uh, a smart this smart traffic lights in which there's a camera, if there's a particular ambulance or something, then it will be showing red or the output will depend upon the road, then we'll be using a microprocessor. Okay. Okay, yeah, here it is. Stop screen, share screen, application window. Yeah. So this is like how our Arduino IDE looks. We have two system over there, over here, void setup and void loop. Okay, void setup and void loop. Whenever we are working on a Arduino system or any hardware system, we need to initialize our pins first. Like what pin will be a output, what pin will be a input, what will be our baud rate. Other are not. Okay, no. Okay, so here it is. Whenever we are working on a system in which basically a hardware system, any kind of hardware system, we want to establish, we always establish there's a protocol. Basically we always establish that this particular pin is output, this particular pin is input. There are two basic reasons behind this. That the first is what we want, like we want a power managed system, because over here we only have like a minimum of 250 milliampere current, so we want to use that precisely. I don't want to distribute all my current or all my voltage to every port on the Arduino. So what we do, we deliver the current or voltage over a certain systems, like certain pins basically. So over here we use void setup. To initialize a pin as an input and output, we use a function named pin mode. Okay, pin mode, let's say 12th pin output. Using this particular function, we initialize the 12th pin as a output pin. Okay, if I want to do the same for input, don't think, I just have to change input. Okay, let's say 9th input. Right now my 9th pin is a input pin and my 12th pin is a output pin. Is that clear? Okay, so let me comment this. So let's make a hello world system in a hardware world. Let's make a blinking LED system. Okay, so a basic thing is, whenever we are working on a LED, or if we want to blink a LED, there are 4 steps. Like uh, how we think. First we turn on the LED, then we turn it off, then we wait. Sorry, first we turn on the LED, then we wait for some time, then we turn it off, and then we turn it on again. Okay, so basically whenever we are developing a system, we need to crack it in a steps. So the first is, first if I want to give a digital output, I need to write digital write. Okay, digital write. So digital write is basically a microcontroller or a Arduino giving a output. So digital write 12 high, which means whatever the value initially was for the 12th pin, it will be high for this particular instance. Okay, sorry, I forgot to tell you what is void loop. Void loop is a part of a system in which we put that particular code that we want to repeat again and again. Like if you also have a comment, put your main code here to run repeatedly. So this is a basic difference between a Raspberry Pi and a Arduino. That that this is a basic difference between a Raspberry Pi and Arduino. That if we want to run a code repeatedly without any sense, like अगर मेरे को एक गधा चाहिए, my microcontroller will be a गधा. अगर मेरे को एक इंसान की तरह सोचना है, then I'll be using a microprocessor. Okay, गधा क्या करता है? गधा बार बार एक चीज को रिपीट करता है, सामान उठाएगा लेके जाएगा, उठाएगा लेके जाएगा. ठीक है, so microcontroller is a गधा. As simple as that. Okay, digital write 12 high, then delay. So the delay function works in a millisecond. Okay, delay is basically when we pause the our system for a while. Now we have to turn the light off. So digital write 13 low. Okay, now we have to turn keep it off for a while and delay 1000. Okay, or we can use, there's one more function for the same, delay micro microsem delay microseconds, in which we have a minimum time at in microseconds. So I need to 1 2 3. Okay, is it clear? The argument for a delay function in nanosecond. Okay, so I have a question over here. The argument 1000 provides in delay function is in nanosecond. No, Karishma. The delay function uses a this thing. Sorry, a millisecond system, and a delay microsecond system. Delay microsecond using the microsecond system. Okay, so here's our code. Let we go. Let's go to a simulation system to use this code. Okay, I have a Tinkercad system. Okay, just wait a second. Okay. Okay, guys, I'm gonna share the different screen. Just wait a second. Chrome tab. Okay. Okay. So here I'm on a Tinkercad simulation environment. Okay. Here you can see the wire is connected to a 13 pin. I'm gonna connect it to a 12 pin. Okay. So LED is connected to like a shorter leg is connected to ground, and a longer leg is connected to a resistor to end then a 12th pin. Okay, code, like we have a code over here. Let's delete it and have the own system and start simulation. Okay, sorry, I wrote 13 low over here. I should have been writing 12 low. That's why the LED wasn't turning off. One, two, three. Let's go for a normal delay then over here. Okay, you guys can see that the LED is blinking. Let me change the color of LED so that it's visible to you guys. I guess white will be more visible. Okay, is it visible? Okay. Yes, Kanshu, you can use a simulation. There's a site. If you want, I can send you guys the link for the same. Let me see. Here's the link for the same. Okay. Hitesh, it is Tinkercad. Okay. Okay, remove the comment from the screen. Okay. Is it clear to you guys? True hacker. Delay 1000 is 10 second. No. Whatever your name is, the delay works in a millisecond system, one upon 1000 system. Okay. I've sent the link, guys, if you want. Okay, is it clear to you guys? Okay, nice, thank you. Okay, so let's make a LED system, sorry, a traffic light system over here only. Okay, first of all, I have to stop simulation. Okay, so a basic thing, like how does a traffic light works? So in a particular traffic light, we have three or four, like three lights over there. So I need to add different LEDs. Okay, red, and also a green one. Okay, it's red, yellow, green now. So I'm gonna turn it to red, yellow, and a green. Ground, common grounds, and I have connected the yellow to 11th pin and green to 10th pin. Okay, so I need to write a code for the same. So now the difference will be like as soon as the red lights turn off, the yellow light turns on. Okay, so digital right, 11 high, sorry, high. Okay, then we have a delay for 1 second. Then digital right, I'm gonna copy the same code. Digital right 11 low. Okay, then as soon as the yellow light turns off, the green light will turn high. Again delay, sorry, low, and 10. Okay, so according to this first line, the red lights turn on, it stays there for a second, then it's turn off, it's shut off. Then as soon as the red light shut off, a yellow light turns on, and it stays in the same state for a second. Then in a after a second, it's turn out. Then the same for a green light. Start simulation. Okay, I guess it is visible to you guys. Okay, got this. Got this. Thank you, Shakib. Sir, at the junction there are four sides. Then we can use. How will it work? Sir, at a junction there are. Wait a second. Wait a second. Wait a second. There was a good question somewhere. Okay. Junction there are four sides. Then we use these light at that. How will it work? Sandhya, can you be some more specific? Like, I cannot understand your question. Okay. So, yeah. Okay. Next is stop sharing the screen over here. Application window. Yeah. Okay. So a lot of you guys were asking me, or like, in which language do we use Arduino? The language will be C. Okay. It provides us a serial monitor to see a serial data from a USB and virtual COM port. Okay. So I'm gonna show you guys something. Wait, just okay. Application window. Okay. Okay. So let's say we are using the Arduino for some kind of input. Okay. So we have a option to use our serial monitor. Okay. Right now it will not be showing because I don't have any Arduino board connected to my system. Okay. So we'll be using serial monitor just to monitor the input at any instant. Okay. We also have different board over the here. For example, if I connect any other board than Uno, I have to change my board from here. And port system. Port is a your hardware port from which your this Arduino is connected. Okay. Okay. Allows one-click compilation, verification, and burning of code onto Arduino. Okay. We have discussed this void setup and void loop. There are three type of variable in Arduino: char, int, long. You guys know about all this or not? Okay, I'll be needing your input on the same. Okay, I got a question over here. What is void loop and void setup? Void setup is basically initialization of our pins and our baud rate, speed, and just that. Okay. And void loop is a part of code in which basically repeat itself again and again. Okay. Then char, int, long, sorry, char and long data type variables. Then few reserve constant, high, low. So when we wrote high over there, like a digital write 12 high, it gave 5 volts output over there. Okay. Low, 0 volts. Input, it initialize the pin as input. Then function so output, it initialize the pin as output. Conditional statement are as same as processing. If and else statement, if else and for statements. And we can have a function over there. Okay. We can have any type of system. For printing over here, we use serial.println. Okay. For loops, for loop, and for array, we use int bar. Okay. I guess you will be needing this for as soon as we open the Arduino programming ID, we write the code, then we verify by using this particular button. I'm going to show you this. I guess it's not shared to you. Just wait a second. Yeah. As soon as we write a code at any time, we need to verify it, for which we need to save it first. Okay, done compiling. Okay, so this done compiling means that the code is valid and code is okay, like we can process the code further. I guess just wait a second. Hide, sorry. And then and do. Okay, so as soon as we compile and verify the code, we just click on a different button, that is our, where is, just wait a second. I guess I can have my entire window over there. Stop share entire window, share. Okay, so as soon as we are good to go with the code, we press this upload button, and as soon as we use press this upload button, the code is burned to the our microcontroller. Okay, simulator, you don't need that. Okay, that will be all about Arduino. Like basically what we learned about digital write over here. Okay, I got a great question over here about baud rate. Okay, baud rate speed, basically we use the system in, just give me a second, application window. Yeah. Okay, so what is baud rate speed? Great question, Uma. So baud rate speed is serial dot, sorry. Okay, baud rate speed is basically uh, what we do. For example, we are working on two different systems, we are communicating between two different Arduinos, so we need to initialize the baud rate, for which we have a function called serial dot begin, and s will be capitalized. Serial dot begin 9600, let's say, which means that 9600 bytes will be sent out every second, and the same line will go on the receiver end, which will initialize that particular system is entitled to gain 9600 bytes per second. Okay, so what's the difference between, like, why do we use serial dot begin and serial dot begin or baud rate? For example, like right now I'm communicating with you guys, so I need to maintain my speed at at such a level that you guys will understand that particular concept or something, or whatever I'm saying. If I go something like something and in a great speed, and so you guys will not understand it. So we need to initialize the input speed and the output speed, Like in this speed the data will go, and in this particular speed that data will be collected. Okay, so we need to make sure that the input speed and output speed or the baud rates should be same for a communicating system. Okay, okay, hide. Okay, so I'm gonna add Rohit sir. He'll be telling you more about the certificate and all. Rohit sir, are you online? Rohit sir, Vedansh sir.
Hello. Yeah, I'm just calling you, sir.
Okay, so they'll be telling you about the certificate. You guys were quite certificate calling thing. You guys were quite interested in certificates. Mm, okay. Yeah. Why not? Application window, Chrome tab over here. Yeah. Okay. So someone wanted to understand the traffic light code again. So void setup in
Section,
which
sir.
we. Okay, I did something wrong over here. I just needed to add 2 more lines.
Section, sir. मैं ये कह रहा हूँ एक सेकंड में प्रेजेंटेशन दे देता हूँ थोड़ी सी.
रोहित सर 2 मिनट रुक जाइए प्लीज. मैं
ठीक
जरा
है,
एक,
ठीक है,
एक क्लास बच्चे का एक डाउट आया है वो समझा दूं. Okay, so yeah, over here 10, 11. Okay, so basically we initialize the 12th, 11th and 10th pin as outputs. Then we use the function named as digital write to give a output. Digital write is used to give out a output 12 high, which means we have given the 5 volt output at 12th pin. We stayed in that particular state for a second, like we gave 5 volts or to 12th pin for 1 second. Then we gave 0 volts on 12th pin. Okay, and simultaneously gave 11th pin a 5 volt output, and so on. Okay, so 11th was high, then there was a delay for a second, then 11 was low, then 10 was high. Okay, okay, why use 9600? Okay, there was a question somewhere, why use 9600? I can't find it again. Okay, yes, I got it. 9600 is basically a pre-initialized system. For example, let me show you something. Just give me a second. Share screen, window, sketch, tools, and we have. Okay, we don't have a. Okay, just give me a second. Okay, it will not be open. Okay, so we have different baud rates like 9600 and 9600, 10500 something, and so on. Okay, sorry, 1,50,000 something. We have pre-initialized them. So do we need to declare 11th and 10 as output too? Yes, we need to declare it. So can we use nested if condition? Yes, we can. Okay, just a second. My battery is low. Just wait a second, guys. How do we know that baud rate must be used for different sensor? Normally, all the sensors are sensor use 9600. Sort of. Okay, Arduino is case sensitive. Arduino is highly case sensitive. It uses a camel case. Okay. Uh, can you share the document? Yes, I will share the document. Okay. Atmega 8 has what use? Can you answer once confirmed? Won't. Okay. Atmega 8 micro. Okay, Atmega 8 micro is just a Atmega 8 micro. Okay. Atmega 8 micro is just a microcontroller. Okay, nothing else. What is meant by camel case? Camel case means if there are two words, for example, digital and write. So digital will start with a small caps lock off. Then write will start with caps lock on. Okay. Okay. What is the link? Okay. How Arduino is related to IoT? Nishant, the most of the Arduino IoT system, like basic IoT systems, are set up on Arduino only, or any microcontroller in that case. Okay. Rohit sir, I'm gonna join you. I'm gonna add you. Okay.
Hi guys, Rohit this side from VAC, and I'm here to tell you कि this is just a essence of IoT. Okay, this class is not a full-fledged class of IoT. It is just an essence, and yes, you will get the certificate for that. But before that, I would like to tell you, if you want to join the full course of IoT, we are starting a batch from Monday, and you will get 10 days class, and the duration will be 4 hours every day. So it is a 40-hour session in which you will get to know everything about IoT, right? So first of all, जो मतलब the thing which you have understood in this session is what is IoT, what is the usage of IoT in the industry, and what is the future of IoT, right? So if you want to learn it fully, you can attend our full webinar, right? So in IoT, you will get 10 days classes, which is online plus offline, and you will get a 4 hour class every day. It will be a total 40-hour session, and we are starting a batch from 4th of May. And the fees, original fees is 4,000 rupees, but we are giving 1,000 rupees off to every student who will join or who will pay their fees latest by midnight, right? So course curriculum link will be shared soon to you, and I already told you about the discount. And this is the sample certificate. You will get three types of certificate. First, it will be a VAC certification. It will be in IoT. Second one will be a HP certification, right? And for that, you have to give an online exam on HPE portal, and you have to clear it by minimum scoring 60%, right? So throughout the training, trainers will guide you ki how HP will ask the question, how you have to answer them, what will be your overall strategy, what will be your total strategy, right? To pass the exam. And After that, you will get an internship letter from our side, because this training is a project based training. You have to make project after every class. It will be like a small task which you will be assigned after completion of the class. On that day, we'll provide you a VAC internship letter of 45 days, so that you can show it for your future endeavors in your summer training reports or final exposure reports, or for your further studies or jobs. So the benefit of joining with VAC is you will get LMS system, means you will get online classes every day, and after the completion of online classes, you will get the recorded session of every class, and industry update curriculum we are teaching. And Mr. Saksham is a very good trainer. He is taking classes of IoT from past 1 year with us, and he has a very good reputation in various IITs and NITs. Students are very like they respect him, right? And you will get recorded session assignment, and in a batch only 10 students will be there to you can like only a 10 student batch will be there. And these are the counselor number. uh, you have some counselor number, you are like you are added in their contact list. You can contact them and you can ask for the link or your for further queries. They will sort out all your queries, and we are starting IoT batch from Monday. So you have today, tomorrow, and Sunday time only. And if you are booking up your seat uh, like before midnight, you will get 1,000 rupees off in the fees. And this is the webinar certificate formality, and I'm sharing the link in the chat box, and you can fill that form, and you will get your certification formality done by maximum by tomorrow, or maximum by Monday. You will get your certificate over mail. And for further queries, I have given my number. I'm taking to you that slide. This is the counselor number. You can contact any counselor through WhatsApp or through call, and they will tell you about there are discounts, there are more discount or not, how you will get your certificate, what is the formalities for joining the classes, right? Everything about the webinar. So you can contact them. You can write down their number. Those students who don't have their those counselor number, they can write down their numbers. Saksham sir. I think we are done with our part. आपको कुछ add on करना हो तो आप कर सकते हो.
Yes, yes, sir.
Hmm. And sir, one more thing I would like to tell every student.
Yes,
Friends, if you are attending that IoT webinar for just for the certificate, let me tell you one thing very frankly. In just 1 hour session, you will not get like you are getting certificate, but don't consider if this certificate will be a very huge value in your career or in your CV, right? So it is. Let's suppose I'm giving you a small example. Whenever you purchase a book, right? So you don't read whole book in a day, right? First of all, you read the index. What chapters are there? How many chapters are there? How many topics are there, right? So Saksham sir has, like, he had all like only told you the thing which he will teach you in the full webinar, right? The full course we are going to start from Monday. So it is just a essence of the IoT, not a full-fledged course. So the certificate which we are providing for that free webinar, it has zero value in your career and in your CV, right? So if you guys are attending just for the certificate, so my personal suggestion for you is you can take that certificate, but it has zero value. Go with the full webinar course, okay? So you will get three types of certification: one from WAC, one from HPE, and third one the internship letter from WAC. Saksham sir, if you can add something.
Yes, why not? Okay. So I guess my screen is shared to you guys, and so here's our plan. Like a lot of you guys are asking for projects and job opportunities. I can see in the comment sections. So this particular PPT will give you all the answers. Why IoT? Okay, first of all, why do we learn IoT? Have you guys learned about heard about Industry 4.0? There's a it's a quite going on term these days, like Industry 4.0 and all. So the thing is, as soon as we proceed further with the system and we are going to like next level of industrialization, we will be going for more connected system. And as you guys can see, like these days we are all working from home. Yes, like so in a while, like I guess in a 10 years span or a 5 year span, we all will be working on from home only, and all the system will be based on IoT. Like even the machineries and all these systems will be working on IoT. Okay, companies that uses IoT: Google, Intel, Microsoft. uh, Fitbit. Like you guys must have known or use Fitbit or MI band. What does it do? Like it collects the data from our collect the data from our from our body and transmit it to different different clouds and all, cloud servers and all. Okay, then basically our mission career towards data science, product development, IIoT, industrial IoT, and IoT. Okay, do one thing, guys. Just listen to me once, then add the questions in your comment section. Don't add because I cannot see the comment section and I'll not be able to answer you guys. Okay. So the fundamental of the IoT course is basically fundamentals of IoT, real world projects, basic guidelines, IP networking and for connecting system, data analytics for IoT system. Because as soon as we reach to a system in which our devices are connected, we always need data analytics. We always need a smarter system. We always need a system that can tell that this thing can happen. Okay, for example, your Fitbit shows you that sorry sorry, your Fitbit shows you that you are on in a 55% of a healthier population, 95% of healthier population in your city, and so on. So that is basically data analytics. Okay, general requirement, we don't need anything from you, just motivation to learn. Program specific requirement, we need Arduino IDE and a text editor in your system installed. So device curriculum, Python. Then there will be functional programming. In the module 3 will be sensor interfacing. Then there's Raspberry Pi. Sensor will also contain IoT components. Then there's IP networking, cloud programming, and then data analytics. Projects that will be there: TikTok to game, temperature detection system, movement alert system using PIR sensor, internet-based surveillance system. Oh, sorry, smart temperature control system, Google Assistant-based home automation system. Skills that you will learn over there: GitHub, function and command line syntaxes, Python syntaxes, problem solving skills on HackerRank, product design, utilizing package manager, Arduino, Node MCU, AWS, GCP, AWS or GCP, or AWS or GCP. I'm not gonna have both of them. Either will be going for Amazon Web Services or either will be going for Google Cloud Programming. Okay, Blink, data analytics, and I don't have a Raspberry Pi over there. Raspberry Pi will be also learning Raspberry Pi. Okay, so these are the snippets from some projects. Tic Tac Toe game, smart temperature monitoring system, and a Google Assistant based home automation system. Yes, now I can take questions if you guys have any questions.
They are
Don't
concerned
ask
about
any.
their certificate.
Not answer that. Rohit sir and Raj sir will be online after this. Ask them. If any technical questions or any doubts are there, just ask now. Mm, okay. Yes, Sangeeta will be starting from scratch. Scratch. Wait a second. Wait a second. Let me do this. Okay. Job opportunities and IoT, Bhupender. A lot of companies are offering a great package for IoT. I just got a like one of my student got an offer from Siemens last week, and the basic package was 16 lakhs. Okay.
Saksham sir,
The process of installation of Arduino.
Saksham sir. Hello,
Guys, I'll ask Rohit
Saksham
sir
sir.
or Vedant sir to
Wait
send
a sec,
you a.
wait a sec, wait a sec, wait a sec. Nigel Joseph is in the line. He has participated in IoT, so he's attending your class from Monday. So, iska ek question है, what is the difference between IoT and embedded system? If you can clear his doubt.
Sir, I'll do that in a while. Okay,
Okay, okay, okay.
just a second, sir. Yeah. Okay. Sir, do we need to learn first Python? No. Okay. Yes, we'll be starting from scratch. Which platform is used for Arduino? Arduino IDE. What is the difference between R language and Python? R language is basically for statistics. Yes, Sangeeta, you can use your desktop or laptop. There's no problem with that. Since the system need to be connected, that means it needs all the time internet. Yes, Nishant. Sir, you are using Python in training. I just know basics. No issues, Justin. Will be teaching you the required Python system. Okay. Arduino support Java language. Uh, Maheshwari, I seriously don't know about this because I never used this, and I don't think it uses Java. Okay, what is the difference between IoT and embedded? IoT is all about connected systems. When we connect embedded systems to different embedded system, that is IoT. And when we think about embedded systems, is basically when we think about and say it's something about a whole system on a chip. Like, am I clear, Joseph? I guess you were on the call. Okay. Scope of IoT in software domain. Uh, okay. सही थी. Okay. In software domain, will be like we have a lot of jobs. Like, let me show you guys something. I guess I have a document for the same. I cannot find the document basically. It have all the jobs and all for for IoT and IoT engineers. And as soon as we go to software domain, we don't have the like in IoT we have different parts: the hardware part, the embedded part, then there's cloud part, then there's data analytics part. So in software domain we have jobs in that cloud part and this data analytics part. Okay, what kind of assignment will be given, Sangeeta? The assignment will be of coding assignments will be there. Sangeet, sorry. Okay, do we have to purchase IoT for training? Yes, Arduino for IoT training. Yes, you have to. Okay, are there any more questions? Rohit sir, do you want to add something?
To add, students, we are providing you that like IoT training. There are two things. If you want to join 4,000 wala fees, okay, so you are getting 1,000 rupees off in the fees if you are paying that fees before midnight, right? And you will not get any kit in it, right? For kit, you have to pay 1,000 rupees extra. If you want kit, will deliver at your home. Vedansh?
Hello everyone. So
Vedansh,
let's start this webinar. Yeah,
I think Saksham has completed his like
yeah.
thing,
Let's
right?
end this webinar. Fine.
Mm-hmm.
So thank you everybody for joining with us. We are coming with more webinars in further weekends and weekdays also. Maybe upon Python programming, Android app development, artificial intelligence. All these webinars are lined up. So for that, what you guys can do is you can subscribe to our YouTube channel and also our Facebook and Instagram page. So you get notifications as per the webinars are out. Also, it would be great if you join our full courses. These are small courses that we are providing, a 40 hours course that will be providing you with so lot of world class certifications, and will also help you fetch jobs, because these HP certifications and Microsoft certifications have a trademark. If you are learning some course and you are certified with this certifications, you are very easy to fetch jobs either in India or if you apply abroad. So we would definitely suggest you guys to go for our program and learn IoT through Mr. Saksham as much as you can. And yeah, the link provided is for Internet of Things only. The site didn't got updated, so that's not an issue at all. You guys are filling the forms. I'm checking it at the back end. All the entries are coming for the Internet of Things, so please don't worry about this. The certification link has been already been distributed. I'm sending it for the last time, and we will be ending this webinar over here. Thank you, everyone. Thank you so much.